All right, now that we've learned what a string is and how it works, let's move on to some problem solving. We'll go through 4 beginner-level string problems together, step by step. Each of these will show us how powerful strings can be. Problem 1. Reverse a string. Let's begin with a very basic but common problem, reversing a string. Imagine the string is hello, and you want to reverse it to Allah. Approach. We'll use a simple loop that starts from the end of the string and appends each character to a new result string. Pseudocode. Function reverse strings. Create an empty string called result. For each index I starting from the last character to the first in S. Add character at position I to result. Return result. Dry run. Input equals hello. We initialize an empty string result equals empty string. I equals 4 S 4 equals O. Result equals O. I equals 3 S 3 equals L. Result equals OL. I equals 2 S 2 equals L. Result equals all. I equals 1 S 1 equals E. Result equals all. I equals 0 S 0 equals H. Result equals Allah. Final output, Allah. Time complexity, O of n. We loop through the string once, where n is the number of characters. Space complexity, O of n. We're building a new string of the same size. Problem 2. Check if a string is a palindrome. Now we'll check if a string is a palindrome, meaning it reads the same forward and backward. For example, madam is a palindrome. Approach. Use 2 pointers, one from the start, one from the end, and compare characters moving inward. Pseudocode. Function is palindromes. Set left to 0. Set right to length of S minus 1, while left is less than right. If character at position left is not equal to character at position right, return false. Increment left by 1. Decrement right by 1. Return true. Dry run. Input equals madam. Left equals 0. Right equals 4. S0 equals M. S4 equals M. Match. Left equals 1. Right equals 3. S1 equals A. S3 equals A. Match. Left equals 2. Right equals 2. Both point to D. Match. All characters matched. Return true. Time complexity, O of n. We're visiting each character pair once. Space complexity, O of 1. No extra space used, just 2 pointers. Problem 3. Count vowels in a string. Let's count how many vowels are in a string, vowels being A, E, I, O, U. Approach. Loop through the string and increase a counter whenever a vowel is found. Pseudocode. Function count vowels as. Define vowels as the set A, E, I, O, U. Set count to 0. For each character C in the string S. If C is in the set vowels, increase count by 1. Return count. Dry run. Input equals education. E is a vowel, count equals 1. D is not, count equals 1. U is a vowel, count equals 2. C is not, count equals 2. A is a vowel, count equals 3. T is not, count equals 3. I is a vowel, count equals 4. O is a vowel, count equals 5. N is not, count equals 5. Final count equals 5. Time complexity, O of n. 1 pass through the string. Space complexity, O of 1. Set of vowels is fixed, no extra space with input size. Problem 4. First non-repeating character. Now let's find the first character that doesn't repeat in the string. For example, in Swiss, W is the first unique character. Approach. Step 1. First pass. Store frequency of each character in a map. Step 2. Second pass. Return the first character whose frequency is 1. Pseudocode. Function first unique chars. Create an empty map called frequency for each character C in string S. If C is already in frequency, increase frequency C by 1. Else, set frequency C equals 1 for each character C in string S. If frequency C equals 1, return C. Return -1 if no unique character is found. Dry run. Input equals Swiss. First pass. S. Frequency becomes 1. W. Frequency becomes 1. I. Frequency becomes 1. S. Again, frequency becomes 2. S. Again, frequency becomes 3. Second pass. S. Frequency equals 3, skip. W. Frequency equals 1, return W. Output, W. Time complexity, O of n. 2 passes, still linear time. Space complexity, O of k, where k is the number of distinct characters, max 26 for lowercase. Summary of all 4 problems. Problem, reverse a string. Time complexity, O of n. Space complexity, O of n. Problem, check palindrome. Time complexity, O of n. Space complexity, O of 1. Problem, count vowels. Time complexity, O of n. Space complexity, O of 1. Problem, first non-repeating character. Time complexity, O of n. Space complexity, O of k. So, by mastering these foundational string problems and understanding their logic, time, and space complexities, you build the core thinking required to tackle more advanced problems with confidence.